Guys, today we're going to talk about LeetCode 719, find kth smallest pair distance. Question is, given integer array, return the kth smallest distance among all the pairs. What is the distance? Is a difference between two given elements. For example, there's an input array 131. So for the first element, you can find two pair, 1, 3, and 1, 1. 1, 3's distance is 2, 1, 1's distance is 0. And for the second element, 3, you can find a pair of distance, 3, 1, which distance is 2. So the k is 1, you should find the first smallest distance and sort the result, and finally find the first smallest distance is 0. So let's begin with the naive solution. For a given array 3, 4, 1, 2, 5, 3, 7, 5, firstly just sort them. We need to sort them and put it here. Secondly, create a new array count. The length is the largest number in the sorted array plus 1. So the length is 8. The third step, you should find out all of the distance and store them in this count array. For example, the element 4 and element 3, their distance is 4 minus 3 equals 1. So the distance at index 1 should increment. So using this double loop, we could keep track of the number of distance into this count array, store them in the count array. And this is the reason why I created an array based on the length of the largest number, because theoretically you could have at most n plus 1 distance. For example, for these two elements, 3 and 3, their distance is 0. So just increment index 0, because in this situation, index equals to distance. So distance 0 is the number at the index 0. And for element 1 and 7, the distance is 6. So we just need to increment the number at index 6, because at this index we are storing the number of distance, which is 6. And theoretically, if there is element 0, the largest distance is 7 minus 0 is 7. So the largest distance is 7 and stored in the index 7. Okay, the fourth step, just look through the count and find out which is the kth smallest distance. So let's look at the Java code. It's really intuitive. Firstly, create a new count array based on the largest number of the original array, and using a double loop to find out the number of distance. And thirdly, loop through the count array and find out if the current number of distance is bigger than k. If it is, return the index immediately, because index equals to the distance. And the type complexity of this code is n to the power of 2 because of the nature of the double loop. Okay, I'll introduce you a LeetCode solution based on binary search. We still use the last sorted array, and in this situation we keep track of 2 pointers, start and end. And then we calculate the distance range, which is 0 to the largest number minus the smallest number, which is 7 minus 1 equals 6. So the distance range is between 0 and 6. And in this situation, we use K50. And if you're familiar with the binary search technique, you can find the left and right. The left is our smallest bound distance range, and the right is the upper bound of the distance range, which is 6. And mid is left plus right and divided by 2. And the reason why we use 2 pointers is like a technique of sliding window, just to calculate the number of distance in that situation. So let's take a look at the example here. Firstly, start and end point are both pointed at index 0. In this situation, the count is 0. Is end minus start is 0, which means because the question answer is not allowed us to use the same element. So we just move the endpoint. And in this situation, we have count 1 because we have only one pair of distance, 1 and 2. And move the end to the next step. Calculate the count equals 2 because in this situation we have 2 new pair of distance, 1, 3 and 2, 3. So in this situation the count is 2. Move to the next. Calculate the count 3. We have 3 newly added pair of distance, 1, 3, 2, 3 and 3, 3. Move to 4. Calculate the count equals to 4. Notice that our mid is 3, which means we need to find out the distance which is smaller or equal to 3. So if we keep moving the endpoint to 5, we can find out that our largest distance is 5 minus 1 equals to 4, which is bigger than our mid. So we should mutually move our start pointer. So when we move to 5, the start pointer also moves to the next element 2. In this situation, our largest distance is 5 minus 2 equals 3 is equal to mid. So this is a legal pair. And we also need to calculate the count, and end minus start equals to 4. And next, move the endpoint. And since they have the same value, so this is still a legal situation. Calculate the count 5. And next, the endpoint move to 7. And this is quite exactly like the sliding window. The start point is keep moving until it reaches a legal pair, a legal situation. So the start point stopped at element 4. In this situation, the upper bound is 3, which is equal to the mid, so the largest distance 3, and calculate the count in this situation is 3, and we have 4 newly added pair of distance, 4, 7, 5, 7, and 5, 7. So the count is 3. Finally, we calculate the total number of count, 22. It means that when the distance is smaller or equal to 3, we have 22 distances. Obviously, this distance is bigger than k, so we need to, just like a binary search, we need to reduce mid and try to find out a smaller count. So the left point is still 0, and right should equal to 3. So for the mid equals to 1, we need to find out the distances which is smaller or equal to 1. Still that array, start and end pointer are both pointed at the 0 index. Calculate the count and move the pointer and calculate the count. Since our upper bound in this situation is 1, so when the end pointer moves to 3, and we need to move start pointer also, and then calculate the count. Calculate the count, and we also need to move start pointer. Don't forget to calculate the count. Move and calculate, move and calculate, and move. Since our upper bound is 1, in start point for start pointer, I can't find any legal situation before the starter pointer reach at the end of the array, so calculate the count, which is 0. We have no legal pair of distances in this situation. So the total number of count is 9, is smaller than k, and it means that we need to enlarge mid to allow more and more distances to be counted. So we just enlarge our left bound. Our left bound is equal to mid plus 1, if you are familiar with the binary search technique. And left is 2, right is still 3, or mid is 2 plus 3, and then divided by 2. Set the 2 pointed at the start point. Calculate, move, and calculate. Move, calculate. And in this situation, our mid is 2, so we allow the largest distance is 2, so we need to move the pointer and calculate. Move the pointer, calculate. Move and calculate. And move both of them until we reach a legal situation. And to calculate the count too. Okay, let's calculate the total number of count, which is 18. You can find it is bigger than k. So theoretically, we need to enlarge, we need to reduce our mid. And using binary search technique, our right is equal to mid, But if you're familiar with the binary search, when left and right are identical, we need to just return the result, and our result is the left pointer, which is 2. So when we need to find out the 15th smallest pair of distance, the result is 2. Okay, let's take a look at the code here. Firstly, sort the array and calculate the data range. And this part is our binary search. In the binary search, we have a sub algorithm to calculate the count. And just like the step I introduced before, calculate the total number of count. If the count is smaller than or m or k, just enlarge or mid, or left equal to mid plus 1. If the count is equal or small is bigger or equal to k, just reduce or mid, so right equals to mid, until we reach a situation that the left equals to right. In that situation, we just return our left pointer, and this is our k smallest distance